All right, everybody has notes, correct? Thank you, Brian, appreciate that. Okay, today we are doing something we have already done. Today's lesson is not difficult. It is something we did previously. Remember whenever I taught you at the beginning of the year how to get rid of fractions in an equation? Remember whenever we did that? We found the LCD, we multiplied every single term by the LCD to eliminate the fraction. We did that. We made it look pretty getting rid of all fractions and decimals. Remember me saying those words at one point? Now, the same thing is going to apply today. Now, I need your brains to understand the difference between section 8.5, simplifying rational expressions, versus 8.6, solving rational equations. What's the difference between an expression and an equation? An equation has an equal sign, an expression does not. An expression, you make equivalent statements saying that they're equal to each other. An equation takes and has an equal sign in it, and you're solving for the variable. Do we understand the difference? Now, within this, what I want you to get is that we are multiplying the entire equation on both sides by the LCD. When I say the words LCD, where is the LCD? In the denominator. And whenever I say find the LCD, your brain needs to think factor. When I say factor, what does that tell you you have to think about? GCF, either numerical or a variable, and two binomials. Do you understand this? I've been saying these things over and over and over again for a while now, yes? Now, this is a review straight off of one of your old worksheets. So, this is a problem. It's not in your notes. I included it afterwards, so just add it someplace at the top of your margin would probably be in your best bet. Now, how do I get rid of the fractions in this problem? First thing I need to do is locate each fraction. So the fractions that I have are 4, 12x, and 8. And I'm going to look at the 12, and I need to find the multiples of 12. 12, 24, 36. I'm going to stop, and I'm going to ask myself, does 4 go into 12? Does 8 go into 12? No. Does 4 go into 24? Does 8 go into 24? You know what this tells me? 24 is part of my LCD. What else has to be a part of my LCD? The x also has to be there. Do we understand that? So what you're going to do is you're going to multiply this entire equation by 24x. Do you remember us doing this? So go clear over here. If I take 24x and divide it by 4, what remains? 6x. Drop down the numerator of 13x minus 7. Do you remember this? Go to the second term. Is the second term a fraction? No, it's not a fraction, so I straight up multiply them. Do we understand that, yes or no? Equals, go to the third term. Is that a fraction? Yes. So do we divide or multiply? Divide. What is 24x divided by 12x? It is a 2 and drop down the numerator of 5x plus 1. Go to the last term. Is that a fraction? Yes. What is 24x divided by 8? 3x. Drop down the 3 times the 9 minus x. Now what we've done is gotten rid of every one of the fractions. Would you agree? This is something you already learned and already tested over. Do you remember it? Okay, we're applying the same concept to equations with variables of nastiness. We're going to have like x plus 2 and x squared minus 4. Okay? All right, this is like problems 1 through 6 on tonight's homework. The directions in 1 through 6 on tonight's homework will say, find the LCD. Do not solve the equation. So I want you to find each one of the denominators and make sure that they are factored completely. So look at the first denominator. The first denominator I have is x squared minus 4. Is that factored completely? What do I do? There's no GCF, so I put into two binomials. 5 over x minus 2, x plus 2. Do we all understand that? fraction. Look at its denominator. Is it factored completely? Yes, it is. It already has the GCF of x on the outside. I can't split up x minus 2 into two binomials, so I leave it. Now I have to find my LCD. How do I find my LCD? Well, we need to look for any GCFs on the outside of each denominator. Do I have a GCF in the first denominator? No. Is there a GCF in the second one? There's an x. So I have to make that part of my LCD. Do we understand that? Now, I have an x minus 2 here. Do I have an x minus 2 in the other one? Compare the lovely little exponents and take the larger exponent always. So in this case, they are the same, so I'm just going to have x minus 2. Do I have an x plus 2 in each of those? No, but because it's in 1, it has to be a part of the LCD. That is your LCD. Do we understand that? Okay, next one. I need to find the LCD. So I'm looking at the denominators. Can I factor the first denominator? Why? There's no GCF, and I can't put it into two binomials. So with that being said, I need to go ahead and do the second one. So what's the second one going to be? Can I do anything with it? No. So what's my LCD? B plus 2 times B plus 3. That's your LCD, and you are done. This is how you do problems 1 through 6. Yes? We good? Do not solve 1 through 6. Simply find the LCD. Okay, now 7 through 14 on tonight's homework. I can't be a good teacher if I'm not caring and giving you something. No. Okay. First things first. How many fractions do you have up there? 3. My goal is to eliminate the denominators and have no denominators. So in order for me to eliminate the denominator, I have to find the LCD. So what should I do to each of those denominators? Factor them. That means find the GCF and put into two binomials if I can. 2x minus 1. Can I factor that? No. So drop everything down. How are these two fractions attached? So what should I do with the subtraction? Make this addition and make that 1 become a negative 1. Now what about the denominator? Put that into two binomials and write it as what? Two x plus 1, 2x minus 1. Close. You with me? Okay. Equals. Can I factor the last denominator? No. So therefore, drop it down. Okay. Now, I need to find my LCD. Everything's factored. So what is my LCD? 2x minus 1 times 2x plus 1 is my LCD. Do we all understand that? Now, before we multiply the entire equation by my LCD, we're going to find our domain restrictions. Where do the domain restrictions always come from? The denominator. More importantly, the LCD. So our domain restrictions is 2x minus 1 cannot be 0, and 2x plus 1 cannot be 0. So x cannot be add 1, divide by 2, subtract 1, divide by 2. So x cannot be positive 1/2 or negative 1/2. X can be any number it wants to be so far, as long as it is not positive 1/2 or negative 1/2. Do we all understand that? Okay, so now I'm going to solve this. So I'm going to put brackets around my equation. And what am I going to put on the outside of it? The LCD, which is going to be 2x plus 1 and 2x minus 1. Yes? Do we see that? Now, what am I going to get? When I multiply my LCD by the first fraction, what remains? Don't distribute it, just tell me what remains. The x remains, and what else? 2x plus 1. The 2x minus 1's cancel out. Do we see that? Go to the second fraction. Plus, what cancels out? They both do, so what remains? The negative 1. Equals, and the last one. The 2x plus 1 cancels out, so what remains? 4 times 2x minus 1. Your goal is to have no denominator anymore. Your denominator should be eliminated as soon as you do the step. Do we all understand that? So, what do I do from here? Distribute or FOIL, whatever you need to do. So I'm going to have a 2x squared plus an x minus 1 equals 8x minus 4. Yes? Now what? Combine like terms. How do I do that? I need to set this thing equal to 0. And the way I'm going to do that is by finding my variable with the highest exponent. My variable with the highest exponent is 2x squared, and it is on the left-hand side, and the coefficient is positive. So I want to keep it positive. So what I'm going to do is I'm going to subtract 8x, bringing it to the left side, and adding 4, bringing it also to the left side. Yes? Drop down the 2x squared minus 7x plus 3 is equal to 0. Factor into what? The word factor should trigger 2 words in your brain, GCF and 2 binomials. Is there a GCF there? No. Can I put into 2 binomials? Yes, 2x and x. Factors of 3 are 1 and 3, but I need to get as close to 7 as I can, so where should I place the 3? On the outside, and the 1 there. I need to have a positive 3, so my signs are both plus, plus, or minus, minus. Which do I use? Minus, minus, because the middle term is minus. Inner is 1x, negative. Outer is negative 3x to give me negative 7x. Now what? Set each parenthesis equal to 0. How do I solve this? Add 1, divide by 2. How do I solve this? Add 3. Now, I want you to, after you find your answer, ask yourself, is it allowed to be 1/2, and is it allowed to be 3? It's not allowed to be 1/2, because that's part of my domain restrictions. My domain restrictions tells me right there it's not allowed. So that means the only answer I have is going to be 3. Do we understand? 1/2 is an extraneous solution. It appears to work algebraically, but when you plug and chug it back in, it will not give you the right answer. Again? Here we go. Same thing. Let's do it again. Step 1, what should we do? I'm sorry? How many fractions do you have? 3. What do we do next? Factor each denominator completely. So whenever I say the word factor, GCF and 2 binomials. So what do I do with my first fraction? I'm going to put that into 2 binomials, being x plus 1 and x plus 2. Plus, go to the second fraction. Go to the second fraction. Can I do anything with it? No, simply drop it down. Go to the third fraction. Can't do anything with it, so simply drop it down. Okay, so we factored each denominator, so what do I do next? Find your LCD. So how do I go about finding an LCD? I look to see what's in each denominator, and it has to contain every single thing, doesn't it? So I have to have an x plus 2, and I have to have an x plus 1. And I simply compare the exponents. And which exponents do I take, the higher or the smaller? You always take the bigger exponent, the larger one. In this case, they're all the same, so that's why we use x plus 2 and x plus 1, correct? After I find that, what do I do next? Not yet. Do domain restrictions, because you want to know what it cannot be. So if I find my domain restrictions, x plus 2 cannot be 0, and x plus 1 cannot be 0. So x cannot be negative 2, and x cannot be negative 1. Yes? Now what? Now we're going to do brackets. And what do I put on the outside of the bracket? The LCD, which is going to be x plus 2 and x plus 1. When we multiply by our LCD, the goal is to what? Eliminate every fraction, eliminate every denominator. So what will remain when I distribute this? X minus 1, everything cancels out. Go to the second fraction. What remains? 2x, and then x plus 1 remain because the x plus 2's cancel out. Go to the third fraction. What remains? X minus 1, which is already there, and x plus 2. Does everybody understand that? Okay, now what do you want to do? FOIL and distribute where needed. So I drop down x minus 1, 2x squared plus 2x. FOIL first gives me x squared, outer is 2x, inner is minus x, and last is minus 2. Now what? You're going to combine like terms on each side. So 2x squared plus 3x minus 1 equals x squared plus x minus 2. Always combine like terms on each side before you do the whole thing. Fewer mistakes are made if you follow that step. What do I do next? Compare your x squareds. This is a 2x squared and this is a 1x squared. Which side should we take everything to? Why are we taking everything to the left side? Because the coefficient is larger and it's positive, correct? So I'm going to go ahead and subtract x squared from both sides, subtract x, and add 2. Now what? X squared plus 2x plus 1 is equal to 0. Factor into two binomials. X plus 1 times x plus 1 equals 0. So what is it going to be? X plus 1 is equal to 0, so x is equal to negative 1. Box that in and look at your what? Restrictions. Is x equaling negative 1 a possibility? No, it's not. So that means this is not an answer. So what does that leave my answer to be? Not irreducible. No solution. Okay, do we understand that? There's no solution because the only answer that we had was negative 1, and that's not okay. All right, last problem. How many fractions do I have? 2. Are each of them factored? Yes. What's my LCD? My LCD is going to be x minus 5. Then, what's my domain restrictions? X minus 5 cannot be 0, so x cannot be 5. Now what? Brackets. Now what? Distribute it in. What remains? 5 remains, equals, go to the next fraction, x remains, and is the last one a fraction? No, so what should you do to it? You have to multiply, so that's minus 1 times x minus 5. Do we see that? You can't drop the minus sign because you're subtracting off not one term, but 2 terms. So distribute. Combine like terms. So what happens? So what remains? It's always true, and since it's always true, what is my answer? All real numbers except, so it's all real numbers except for x cannot be -5. Do we understand that, yes or no? Make sense? Okay, I'm going to repeat this one more time. And I need you to listen to me and repeat after me. It is in my best interest when I study to redo my notes before the test. It is in my best interest to study and redo these notes before the test. Problems 1 through 6. Find the least common denominator for each of the following. Do not solve them. I repeat, you do not have to solve problems 1 through 6, so please make sure you don't. Problems 7 through 8 and 7 through 14. Solve them and do exactly what we did today. If you cannot fit it on here, because many of you will not be able to, write it on a separate sheet of paper and only put your answers on here. Yes? Okay, you guys may go. Have a great weekend.